Hey guys, so this video is going to be talking about boring out an aluminum bore cylinder. Procedure is going to be the same for an engine with a cast iron sleeve. This just happens to be an aluminum bore, and we'll talk more about that here in a minute. This is a 5-horse Briggs flathead, as you can see. It's an older engine. A little bit of back history on this. They've thrown a rod at some point, and it was outside, and the piston got stuck in the cylinder, so it scored really bad. So we have options. We got a 10 thousandths oversize, 20, and a 30. So we're covered as far as we need to go with it. Now, you normally use a chrome plated piston and chrome rings in an aluminum bore engine like this. The kits that you sell on eBay and Amazon are listed for any of the 5-horse Briggs, and they say it'll work in it. And I did build another engine a couple years ago. They went 10 thousandths oversized with it, and used the same cylinder hone and used the same cylinder bore on the engine identical to this, and I didn't get the clearance quite right on the piston. It was just a little bit snug, and it did score the cylinder a little bit, but that was my fault as far as I can tell. But the motor still runs good and don't smoke very much at all, just a little bit when you give it throttle. But hopefully we get this one just right. We're going to do more measuring than I did on that last one, and hopefully make it work. But the trouble is, this is not a plated piston. The plated pistons are not available in oversizes, so you have to use standard non-coated pistons. So you got aluminum on aluminum, so you take a chance of it marring up and seizing. But just a chance we got to take. That's all we have to work with. The only other option is to have this bored out and a sleeve pressed in it. You're getting in a lot of money doing that, and it's getting harder to find a sleeve for these. So it's kind of an experimental test, but the part that's not experimental is the use of this hone. So if you have a cast iron bore cylinder, this same procedure is going to apply to that. These stones are for a cast iron sleeve, not recommended for aluminum. The only problem is you'll get pieces of abrasive stuck in the aluminum. It can destroy itself. So you just have to make sure that it's scrubbed really good. Then we're going to finish up with a standard cylinder hone just to get a little bit of a smoother finish if necessary. So let's just get started on it. We're going to try to use the 10 thousandths because this is honestly not scored that bad. But it's scored enough where it has to be bored out, and you can't use a standard size in it once it's bored out. I did take a measurement on this, and it read exactly at the top here, because the top of the cylinder is not wore where it's got the groove, and it's showing exactly what the spec sheet says. So we're going to use that as a reference to measure by. This will also square and true up a cylinder. If a cylinder's got out of round or got cone shaped or anything, it'll true it up. You have to use a 1/2-inch drill with this on a low speed setting, and you have to use some type of like cutting fluid or diesel fuel, just anything, as long as there's something in there. I'm probably just going to be using WD-40. It seems to work great for honing. And so yeah, let's get everything set up and we'll go from there. I did want to mention there's going to be 2 other videos related to this engine besides this one. There's going to be one on welding aluminum, because I had to weld the crank cover as well, and there'll be another video on the assembly of this engine running, hopefully. But if you want more history of this engine and everything, which has got some interesting history, feel free to watch the video on the assembly and talking about this engine. I also wanted to show you this. This is the 10 thousandths oversized. Any piston that's oversized will be stamped in the center or somewhere on the top of the piston. Whereas you see this one's 20 thousandths. We also have a 30th stamped as well. The only time you don't see one stamped is when it's a standard size. And that's true if it's chrome or just a standard piston. But what I wanted to show is the top of the piston will start going into the cylinder with a standard size bore. Those pistons are like cone shaped. So you can see, you're really not, 10 thousandths is not that much. So there's a slight chance we'll have to go to 20. And even with the 20, the top of it starts to go in. So you're not really taking that much out of the cylinder. Now let's talk about the hone for a little bit before we start setting everything up. Be sure to read your instructions and watch any videos you can on this. This is the Lisle 16,000. It's a very expensive tool, and it does come with extra stones and the brushes that goes on here. And these are just different grits and stuff. I'm just sticking with the standard ones that was on here. I think it's the middle grade that comes on it. This is for like truing up this if you need to. And like I said, these are like foam guides, and this is your boring stones here. So you tighten this up, and this is what expands it. You just barely got to tighten this as you're doing it, because you don't want to get too much of a bite, and it's maxed out right there. So you only go so far with these. I believe these go up to 3 inches while it was advertised, but the paper says 1 3/4 to 2 3/4. But I'm pretty sure it actually goes up to 3 inch. We can measure it and find out for sure. But this is the drive mechanism for it. And like I said, you have to use a 1/2 inch drill. It's got some torque to it. So this is putting a pretty big load on. I just used a cordless DeWalt that seemed to do just fine. So you got to take these screws out. I've only used this one other time. And you want to tighten them up. Don't get them super tight. This gives you a little bit of flexibility on it. So you want to drive it straight as you can. But if you get offset just a little bit, this will allow it to keep it from knocking or anything or binding up. Kind of lets it free float so it can do its own thing. It's kind of the point of that. And like I said, you don't want to get going crazy with it. You just want to do just a little bite at a time on it, where you'll put too much load and could potentially break a stone or break something here on the drive, or damage the cylinder even more than it already is before you start it. So that's kind of why I wanted to get the extra 20 and 30 thousandths piston. That way, if for some reason we mess something up or we go too far past the 10 thousandths, we can go on to the 20 or even to the 30 if we absolutely have to. But our goal was to go with the 10. So, okay, so this may not be the best setup. I just got it set in the vise. Last time I did it was at the other garage, and it was laying flat down. I think I had it clamped or something, so we're just going to try it like this and see what happens. I got this set so it just barely slides through, and yeah, it's not even really cutting yet. But it's pretty much what the way you want to run this, and run on slow, because it will take quite a bit of load to do this. You got to make sure you don't run into something at the bottom or go out too far with it. I'm just going to kind of look at it. I'm kind of looking at it, so it's starting to come out when this is level with this. The way I kind of got a reference here. This cylinder is not too out of round, because when that other one I did, you could feel it like catching, it's like jumping. Just might start once it's tightened a little bit more. Alright, so now we're starting to cut a little bit. You can feel it kind of getting looser in there. Let's go ahead and take a little look at it and see where the high and low places are in it. At this point, it basically just looks like a regular hose went through it. It's not really starting to cut too much. just a little bit in a few places, so we'll just look at it again here in a little bit. I'm not going to show the whole process when there, because we're trying to keep this video short as possible. I don't like making long videos. I know nobody likes watching long videos. Now it's really starting to cut. You don't want to get it so tight that it loads your drill a whole lot, but you got to get it somewhat tight in order for it to work. See, it's not really doing a whole lot towards the top yet. It's got to true the whole cylinder up evenly, so it's going to take more off in certain spots. And the cylinders usually wear more towards the top because the bottom part, the rings don't come in contact with, so it's going to be taking more off the bottom part to even it up, as you can see. So we're getting pretty even cutting on this. Like I said, don't look too much different than running a regular hone through it, but it's a lot more precise and more controlled because you can adjust the tension on it. So you can't really bore a cylinder out with a regular hone, but you have to use a boring hone like this. So I'm going to do some more off camera, and we'll get back to you here in just a little bit and we'll look at it. But some of the scores are already starting to come out. Like I said, this one wasn't that bad. We want to get the scores out and start getting our measurements. Because if we get it to measurements and we still have scores, then we're never going to have to go to the 20 thousandths. We got a good ways in here. Now the piston is starting to go in just a little bit. And this is the 10 thousandths. It's still very tight, as you can tell, but that's kind of a good way to gauge it as you go. This part of the cylinder is looking pretty good, but it is worse than I thought it was. This side up here still ain't coming in yet. Some pretty deep scores where them piston rings were stuck on the old piston. I mean, it's definitely getting there. For the most part, it's cleaning up, but we may have to go to a 20. Okay, guys, so now we're at the point where the piston goes in fairly easy. It comes all the way out the cylinder, so we know we're not too much further than fitting it for the 10 thousandths. This side looks pretty good, but we got to look at the other part. We still got some deep scores. I mean, they're coming out. It's looking better. This is just some stuff on there, but it's in worse shape than I thought it was. So now we're going to go to 20 thousandths. Hopefully not a 30 thousandths, because it's just, it's going to be the last rebuild of the engine. You have to go all the way to 30. So. Alright, so now we're getting there. Definitely starting to look a little bit better. And the 20 thousandths piston is starting to go in more now. It's still very tight, so still got several more thousandths to take off. And hopefully that'll clear up a little bit more. The rest of the cylinder is almost in, but right here and up here towards the top, that's where that ring was stuck on that piston. I can feel it with my finger. Usually, general rule of thumb, if you can't feel something with your fingernail, then it's okay, but I can feel this with my fingers, so definitely got to go some more with it. Okay, guys, the 20 thousandths piston fits right in here, and you can just barely see those scores, and I think it's going to be just fine because the rings will wear in a little bit. I want to leave a little bit of meat left in case I have to bore it out again with a 30 thousandths piston. But the piston's sliding pretty free, and I checked the ring gap, and I got 6 thousandths ring gap, which is just about perfect. You can move the piston just a hair, so we're right there where it needs to be. So now I'm going to use the 3-stone hone just to kind of get a little bit better finish on this, and then we'll be done with that. I had a whole other video on ring gaps, and usually on small engines, I try to keep it between 3 and 10 thousandths when I rebuild. And most manufacturers recommend not to exceed 30 thousandths when I rebuild. So we're right at 6 thousandths, so we're right in where I usually try to get. But you can't really base this just on measuring the ring gap. You really need to mic this and the piston to make sure your clearances is right. But I've worked on these motors for so long, I know this is just about what you want, so we should be good to go on this. Like I said, we got pretty good finish. I like to get just a little bit better of a hone mark on this with the other hone, then we'll be done. So as you've seen, this is a boring hone, and it's still not the ideal method of boring out a cylinder, especially being in a more controlled environment than just using a hand drill. But this is a finish hone. If you're just installing new piston rings and not changing the size of the bore, then you just run this through here just to true it up a little bit and get a good crosshatch pattern on the cylinder walls. In this case, we're going to use it as like a finish hone, just to kind of get a little bit better surface on this and to finish it up with. But we're not actually trying to remove metal with this, we're just trying to get a little bit better finish. So honestly, the finish hone was not small enough to fit on this. I couldn't use it, so I ended up just using the boring hone with a real light setting on there just to get a little bit better crosshatch pattern. You see, you want these marks to cross just like that, like a 45-degree angle. It's got to be just like that in order for it to work. And you can just barely see the score marks. I can still feel a couple spots with my finger right there, but I don't know if it's going to clean up with even going to 30 thousandths or not. And it's down towards the middle part of the cylinder, and the rings don't come in contact too much with most of that part, just a little bit at the top there, so hopefully it'll be all right. The ring, once this seats in, the rings seat in, it'll be opened up just a little bit more on its own anyway, so hopefully that'll kind of fix itself. But if it smokes excessively and I feel like it's necessary, we'll go ahead and tear it back apart and open it up to 30 thousandths. If I was doing this for somebody, I would go ahead and recommend to take it to 30 thousandths just to do it right. But since it's my own engine and I want to be able to rebuild it again in the future, I'm just going to stop here. I think it's going to be just fine. 98% of the cylinder's in good shape. I've just got a couple little marks here. So I think once the rings seat in, this, like I said, this is aluminum bore, so the rings are going to, the cylinder is basically going to seat into the rings. The rings itself aren't going to seat in that much, especially using the standard cast iron rings. So I think that'll be the best decision on this engine in particular. If this was a cast iron sleeve engine, I would have took it all the way to 30 thousandths for sure. So now I'm going to go ahead and conclude this video on boring out aluminum bore cylinders. This is not the best method. I don't want to start a bunch of debates or anything, but I've done it on another engine and it worked good. So this is going to be the second test of it. So hopefully it holds up good, guys. So questions, comments, suggestions, leave me a comment below. I'll get back to you as soon as I can.